Hey everybody, how you doing? It is Wednesday. Welcome to the unusual things that you can do on a .NET stream. My name's Aaron LeBeau, and today I have started a lunch stream. It'll be every day from 12 o'clock p.m. Central Standard Time, and then here in the U.S. until 1 o'clock. And during that time, I'm going to hang out and just talk about .NET. And I'm not going to talk about the easy things because there's a bunch of people that you can watch on YouTube about .NET when it comes to the easy things. Instead, I want to talk about the interesting things, the things that most people would never do in 1,000 years. Also, pouring one out for Visual Studio for the Mac. Microsoft recently announced that they are end of life in the product, and that makes me super sad. 1 second here. Let's see here. End of life. And let's see here. And you can see here, we've got some news here on it from the Microsoft stuff. Not great, to tell you the truth. I've been a Visual Studio Mac user for an extremely long time. More longer than people would probably realize. So you can see here that we're going to get support until August of 2024, and only for .NET 6 and 7 and Mono, and that's it. They're going to probably give us something for .NET 8, but it's probably not going to be extended to the point that you want it. And they have this in green because they're really trying to just point out there. They say there's alternatives, Visual Studio Code. Visual Studio Code, as we'll learn today, is not an alternative for the amount of stuff that we're going to do. Visual Studio Code, they have a Maui plugin, but it does not work for things that we want to do. You can see here, they're very specific. They say .NET Cloud, .NET Maui, and mobile C# development through C# Dev Kit. What they don't tell you is that there's a bunch of other things in C# land in .NET that you could build that are cross-platform that they don't support. And we're going to try some of those today. One of them is Apple TV. You literally can build an Apple TV app in .NET, believe it or not. Now, why would somebody want to do that? I worked at a company where I literally did this. We think about it for this way. Before the pandemic, before the evil times, the dark times of the force, you would have daily stand-ups, and everyone would go into a physical room, and you would tell the other developers what you're working on and stuff. And somebody, the scrum master, the master of the scrums, would come into that room. They would hook their laptop up to the TV in the room, and they would find, we were using Azure DevOps, but you could use Jira, the same thing. And they would go bring up the board, the current sprint board, so you could see what was going on. This was super annoying. And there wasn't really great reports were kind of there, and then a bunch of custom reports they wrote, and every once in a while they try to bring those up in spreadsheets and this and that. And I was like, you know what? That would be cool. We have Apple TVs in all these conference rooms. Why can't we just have an app that we just launch at Apple TV, and it just shows us all of our sprint status right on the Apple TV app? And it shows us all the little bars. We can see our velocity, all those things that actually count. And so it turns out that Visual Studio, our Azure DevOps, it used to be called something else, Team Foundation Server, but Azure DevOps has an open REST API, so I was able to do that with Apple TV. Now, the company I worked for at the time was this big accounting firm, EY, and they were a .NET shop, so they preferred .NET versus native. So I went around the route of, can I just do this in .NET? And it turns out the answer was yes. I've also written Mac applications, native Mac applications in C#. In fact, Visual Studio for the Mac, which we're going to look at, is actually written in C# using .NET. So that, I mean, think about it from that standpoint. Here's a full functional IDE that's written in .NET that runs and compiles for Cocoa, which is uses the toolkit called AppKit, which is very similar to UIKit, which is how we write Mac-based applications. And so you can do that in C#, believe it or not, which sounds kind of crazy. And for some street cred, if you don't know who I am, my name is Aaron LeBeau. If you were to go to my YouTube channel, /Custoda, shameless plug, but if you go to my playlist, and if you go to the ancient ones, the old Xamarin videos, here is a video of me using a product called MonoDevelop. MonoDevelop was the original version of Visual Studio for the Mac. This is in 2013, folks, 11 years ago. Longer than it was 2012. 2012 probably is my guess. But you can see here, this is MonoDevelop. Xamarin was the company that Microsoft bought. And that is the history of Visual Studio for the Mac. It was originally called a product called MonoDevelop, which you could build Android and iOS applications for only using the native frameworks. Xamarin was very popular. MonoDevelop became a very popular IDE. It was written cross-platform. So it was written using something called GTK Sharp. And they used .NET for the business logic, but the rendering, the UI layer, was actually done in a framework, the GNOME Toolkit, which is more popular on Linux. And so that's how MonoDevelop was built. Well, they eventually rebranded it. They brought a company in to give a modern look to it, and that became called Xamarin Studio. And a third-party company they paid, and this is all history, you can go read on the internet if you want, but I'm just giving you a summary of it. They paid a company to kind of take those GNOME, the toolkit, that GDK, and make it look nice and fresh, right? And you can see here that was the version from 2012. And so I have a video on this over an hour long that explains how to build iOS applications using MonoDevelop in C#. This is 2012, folks. Eventually, this product got called Xamarin Studio. And then from Xamarin Studio, Microsoft bought Xamarin. And they rebranded Xamarin Studio, Visual Studio for Mac. Now, in the last year, I happen to have some inside baseball information because I was part of the... Microsoft sometimes has these user groups for people, big customers that pay them a lot of money. At the time, I was working at a company called EY. They're a big, large Microsoft customer, one of the largest in the world. They have 300,000 people. There's like 10,000 developers there. It's a very large accounting firm, one of the big four, they call it. And because we were such a big customer, I got on a NDA version of hey, this is what we're doing next with Visual Studio kind of group that we would meet every so often. And I met a bunch of people from there. There's some really cool people like Andrew, and I mean, I could go on forever with the names of the people that I met there, but really cool, super cool group that really was passionate about doing .NET development on a Mac, because it turns out that is actually popular, more popular than you'd think. So you can see here from this video, I'm actually going through and showing just how easy it is to kind of do this. But Visual Studio for the Mac was end of life, and we are sad. So the first thing we're gonna do is we're gonna pour one out real quick for Visual Studio for the Mac. We're gonna go into Visual Studio for Mac and take a look at it and maybe try to build some stuff with it and just see, did it deserve its death? And my answer is no. I don't think it did deserve its death. I think it was a great product. They spent a bunch of money during the pandemic rewriting almost the entire thing using Cocoa. So all that GTK that I was telling you about, the GNOME toolkit that they had for the UI, this is all native now. This is literally written as a native product. Now, MonoDevelop was open source at the time. And so you could go download the source and actually build it yourself, which was really cool. It's no longer open source. Really, in my personal opinion, this is my humble personal opinion, they should have open sourced this. They should have given it back to the community, because that's where it came from, the community. And that way, if people are really passionate about it, it could live on. But that didn't happen. At least it hasn't happened yet. And that makes me sad also. I'm going to just open up a Web API 6 project to just say, hey, look, man, this thing works. You can see here, it's an IDE. You have your projects on the left, and there's some cool things. If you know all the keyboard shortcuts, you can make the left go bigger or right by using the Command key, which is the Apple key, and then the Shift key, and then plus or minus. So you can make your UI bigger or smaller. It has all the things that you'd want it to have, like it's got tabs here at the top. You can kind of make your tabs go, split, so you can see two pieces of code at once. Obviously, you go here, you got your toolbox, you got testing built in, Git's built into it. You have the ability to do your document outline and properties, very similar to Visual Studio for the PC in many ways. This is a pretty cool IDE, and this works. I could just literally click this button here, and this should debug in Chrome. Let's see here. I'm going to say install and trust. Oh, it's asking for a password. Let me type this password in real quick here. But this is not what we're going to do. This is easy. This is the easy stuff. This is the stuff that everybody knows works. Look at that. I have an API that I'm debugging live from a Mac using Visual Studio for Mac. This worked. So let's go through and try it out. Let's go click here, say execute. You'll see here, I executed it. I got a 200 response. It looks successful. And there's my weather. I don't have any weather in here because it's just the template that's built in. So I'm literally able to build a web API in like 20 seconds using Visual Studio for the Mac, and that worked pretty well. But I have to stop debugging. But folks, that's not what we're here to do, because y'all know how to do that if you're .NET developers. That's pretty easy. This is the easy stuff. We want to do some stuff that's taboo, some stuff that some may consider taboo. To quote the Emperor from the Star Wars prequels. So let's close this puppy out and let's take a look at what you could do that maybe people would not do. Like, for example, Apple TV. What in the world is this? Apple TV on there. Hey, Taboo, I'm down. Hey, TBD Gamer, how you doing, buddy? Welcome to the stream. Yeah, we're going to do some Taboo stuff here today. We're going to try, we're going to point out some stuff that's just downright broken right now because this product is no longer supported by Microsoft. Boo hiss. I'm going to show you some alternatives of how to get it working. And then we're just going to build some stuff because, man, that sounds like a lot of fun. So let's go through here and take a look at this Apple TV option here. We're going to click continue. It's going to ask us for some stuff. You know, nothing. Let's call this Apple TV POC. We're not trying to break the bank on this. We just want to see, can we really build an Apple POC project or Apple TV project in .NET? Let's go ahead and just put it in my developer folder. Yeah, maybe we'll throw this out on Git. I mean, if we could do cool things with it, why wouldn't we? I mean, that's kind of crazy for someone to go look at some code doing it. Let's go ahead and click create. Now, spoiler alert, I tried this yesterday, and I did not like the results I got. But I could tell you, at least I troubleshooted it enough to get it working to know like where our problems are going to start here. So one, if we look here, we've got a project open, but look at here. Notice the entitlements is listed twice. That's a defect. The info plist is also listed twice. That's not cool. Those files should only be listed in there once. And it turns out they are only in the project once. Well, how do we know that? Well, we can go into here, right click and say, find in files. I want to say, no, show in finder, excuse me. And this should show us the actual code that it generated. And I know that that's probably a little hard for you to read. Let me zoom in on this puppy. We can maybe get a little bit better assessment of this for you, for all you on the stream. Let's just make that so you can see. But if you see here, we take a look here. We only got one info plist file. We only got one entitlements file, but there's already a defect in here where it's showing multiple files that it should not show. That's not good. Let's go ahead and close it to start out with and try to open it again because that's always the solution to all problems, right? Reboot. And look at that. The files are now listed properly. So first problem solved. We're getting multiple listing of that. Now, how does a Apple TV app work? This is the great question to ask. So I have some inside baseball knowledge of this because I've built them before. To start out with, we had a main CS, and that's all applications usually will have some kind of main CS. This is a UI application, which is kind of funny because Apple TV uses UI kit, the same kit that iOS does. So that means your same coding that you'd use for a phone or a tablet. Now, I know you're going to say, well, wait a minute, Aaron, Apple calls that iPad OS. That is a marketing term, my friends. It is a marketing term. Behind the scenes, it is still just UI kit or Swift UI that you're using, and the same rules apply. It just uses different screen sizes. As if you know anything about iOS development, you kind of know about this. We have different sizes in Xcode that we can set, and then it automatically draws UI based on those screen sizes. Sorry for the hydration break there. So we basically are going to start a UI application, almost the exact same way you'd start an iOS application if you were using UI kit. So we have something called a delegate. The app delegate is what's going to handle this, and that is the brains or the beginning of a UI kit or, in many ways, an app in Mac. If you're using AppKit, you also have an app delegate. Now we have some here, some magic things here. Register. We're going through some annotations here, right? We have our window, and your window could be nullable. So we have a question mark here. That's actually good. And then we're just basically saying, hey, if you need to load some stuff when your application starts, you do it here. And when you're done, this application should pop up and run. Now, how does it know what to do? Well, it turns out that this has got a storyboard file in it. And how this happens is that you have to go into info plist and know some knowledge about that. What info plist should have in it is the main storyboard file base name. You can see here that that's main. What that means is when this application is run, it's going to go look in that storyboard file and it's going to find the very first view controller. They call it the root view controller. And whatever's set in that storyboard file, that's what it's going to run. And that's what it's going to try to render. Now, you'll see here, I've got 3 Apple TVs available to debug on, and I'm going to select iOS tvOS 16.14 or 16.4. There's a very special reason for that, and the reason is that I've got 2 versions of Xcode on my computer. To do any kind of Mac development or Apple TV or iOS on a Mac in .NET, you also have to have Xcode because it uses the Xcode compiler to compile things. Now, with .NET right now, it's not compatible with the latest release candidate, the beta of Xcode 15. So I have both versions of Xcode on my computer. But in Xcode, I had to tell it, and I'm going to show you how to do this real quick, because this is where people get broke all the time. They don't know that the command line tools you can set in Xcode, and you must set these to the version that the .NET tools support. So I'm going to open up my Xcode here. It's going to probably open up a project that I don't want to open up, but it's going to do that anyways. We don't care about this. One second here. It's coming up with a message warning me here. I'm going to use the... I'm not sure why it's asking me this. Keep the Xcode version. Keep the Xcode version. Okay. Let's go into Xcode settings here. So we can go that for the menu here. And what you have to do, this is very important. You have to make sure your command line tools under locations is set to the 14 version. If you don't do this, it won't work. You're going to have all kinds of problems. Visual Studio won't be able to see Xcode, and it's not compatible with the latest version of Xcode. Microsoft hasn't done that yet. So if you don't have that set to the old version of Xcode, you're going to run into some problems, and it's not going to be great. You're probably going to be upset, and things will probably not compile. The other thing you have to worry about, since we're talking about like trying to make this work, is let me make sure I have Visual Studio Code Visual Studio selected here. Close my Xcode. I don't need that anymore. Let me get back to Visual Studio here. In Preferences, you have to tell it where Xcode is, and that's under the Visual Studio menu, Preferences, and then you're going to go into the SDK locations, and you're going to go to Apple. And you have to make sure you point it to what version of Xcode. This needs to be a 14 release. You can't use the beta here, okay? So if you have the beta, that's the only version of Xcode you have installed. Sad Panda, you're not going to get this to work. It won't compile. So if you change this, though, you do have to restart Visual Studio, and it should detect that. That's what gives me the ability to see the simulators that I have running on here. Now, the reason why I said I'm not going to use 17, because that's associated with the beta release of Xcode I have. This 16.4 is associated with the 14 release of Xcode that I know works. Now, it's never guaranteed to work, but you're trying to increase your odds of things working. So that's why I'm going to select one that I think I know works. I'm going to go ahead and click the debug button, and we're going to see what happens. Now, yesterday, I spent a whole hour getting this to work. So it should, by theory, work. But let me tell you, yesterday, because I had the beta installed, it took me a lot of work to get my machine to the point where it would work with both the beta and the real version of Xcode installed. And so all the stuff I just walked you through was learning lessons I did yesterday to make sure that this even would work. Now, you'll see here right now, the Apple TV came up and nothing happened. Nothing. This is like blank nothingness. That's normal because the built-in project doesn't have anything of views. There's no hello world messaging even. If we hit this, you'll see I have 2 versions of this app that I have installed on this emulator, the one I did yesterday and one I did today. There's not even a name for the app here, so it's a little kind of broken in the sense that it doesn't do anything, and we're going to need to tout how to do something. Now, this is where Visual Studio for the Mac comes in, and I was telling you that it does not work with VS Code. This is where Microsoft won't tell you this, but I'm going to show you this. The reason why is because to make UI in this, we need something called the storyboard file here, right? And you have to edit this storyboard file in Xcode. What? Yeah, in Xcode. So how you do that is you can right-click here on the storyboard file and say Open with Xcode Interface Builder. Most people don't know this. If you've been around a long time, you do know this, is that Interface Builder was the UI portion of Xcode. It was a separate program back in the day that you would use to modify your UI of your application. And so that's how this kind of works, the magic here. So I'm going to have Xcode open here, and I'm going to say Open with Xcode Interface Builder, and we're going to get a little warning message here. I'm going to click OK. And what should happen is this should hopefully open that storyboard file in Xcode. If it doesn't, then we can't modify this Apple TV app, right? Because if we can't modify it in Xcode, how do we do this? And what's seeing here is it is not let me open in Xcode Interface Builder. See that? I have Xcode open and there's nothing going on here. Let me double click on it and see if it opens up the Xcode window. And I double clicked on it, nothing happened. So this is our problem, folks. It's already busted. Now you're probably saying, this is a pretty boring stream, Aaron. You just tell me that Visual Studio Code that Microsoft just announced is no longer released isn't working with this Apple TV app, which is pretty not very popular for people to be doing, right? So, okay, I get that. Let's try to make this work, though. Let's show you what the possibilities used to be. And for that, we're going to bring in, we had a pitch hitter here. We got our friend Ryder. What the heck is Ryder? That's a good question. Ryder is an alternative IDE that JetBrains makes for Mac, Windows, and Linux that allows you to write .NET stuff. They have other IDEs out there. If you've ever heard of Android Studio, Android developers, yes, Ryder is what VS wishes it was. Ryder is pretty badass awesome. But the cool thing is that JetBrains has more IDEs than just Ryder. They have something called WebStorm. I use it all the time for React development, web development, basically. So that's what WebStorm does. They make a called IDEA that's for Java and Kotlin developers. But Android Studio, the IDE that Google ships for Android, is actually just the same IDE as this. It just has some plugins installed for Android. So that's also based on JetBrains' IDE packages. So how JetBrains works is they wrote an IDE engine, and then basically they ship different language supports based on whatever IDE that you have. So Ryder is the .NET engine, but they have it for just about any language you could think of. Python with PM Charm. They have Ruby, a Ruby one. It's pretty awesome. And yes, absolutely. Peach Storm. If you're doing PHP, it's great. This is the cat's meow. It's pretty great. And it still works. So this is our only hope of having support for this. Now let's go into developer here where I have that code and we have this Apple TV POC. Let's open this in Ryder. Ryder's going to say, I'm not sure if we can trust this person. You know, this person's kind of, this project may be a little shady. You know, it's Apple TV. You know, do .NET developers really want that? We don't know. Now I'm going to admit that Ryder's UI, not 100% friendly here for streams. As you can see here, it's pretty small. I did shift up the code so that we could see it. And the difference, though, is here you can see the icon. I know it's probably a little hard to see on the stream, but it says main storyboard. If I double click on this now, you'll see here it opens up the XML, because storyboards are just XML files. They used to be binary files when they're called something called a NIB, N-I-B. It used to stand for next step interface builder, but then they moved them to something called a ZIB, or an XML interface builder. And then from that, we basically grouped a bunch of ZIB files together, and that became what we call a storyboard file now today. Now, a storyboard file, if you know what you're doing, it's just XML. You actually could go in here and do that. In fact, you could look here and see, here's our view controller. And you can see all the information about the view controller. And if you knew the syntax of this, there's nothing to stop you from doing that. Now, this syntax is terrible. Most people don't even understand how this works. So we want to use Xcode for this. So how we do that is we should be able to say, right click on it and see this open an Xcode button. This one actually works. I know because I tested it yesterday. And if we look here, we've got Xcode open, and here's our UI for our Apple TV app. And like I kind of told you, it doesn't do anything. That's not very useful now, is it? Right? So let's zoom in on this puppy and take a look and see what options we can do. And I want to show you the magic behind why this is one of the coolest things that you're going to see. Because remember, we're talking about an Apple TV app here, and we're talking about making that so I can write it in .NET. Now, we need some UI, right? What do we need? Well, let's take a look at what our options are. We're grocery shopping here a little bit, right? So I happen to know quite a bit about UIKit. I did UIKit for well over 10 years. I know more about UIKit than I do Swift UI, to tell you the truth. I happen to know that there's something called a stack view, a UI stack view. And a stack view is what we want in order to basically put a bunch of UI components together. So we're going to throw out a vertical stack view. We're going to try to kind of go through here, make it the whole entire length of the screen. But we need to do something called constraints. And constraints are the things that all developers hate. They're way easier than you could possibly imagine. Now, I've got these cut off the screen because of the fact that my capture is not there. Let me see if I can bring this up so you can see this, what I did here. See this little set of bars? These allows me to adjust the constraints for whatever I have selected. Now, right now, what I have selected, if we take a look here, is this stack view. That's what I want to, I've got it over here in my tree. I want to modify the constraints for that. So what I'm going to do is click here, and I'm going to say horizontal in container and vertical in container. Actually, what we should be able to do is center this. 1 second here. Nope, it is over here. We're going to add horizontal, vertical. We're going to say, let's grab the, since we've got it here, we're going to put 0 padding in between the horizontal and vertical. Now, if we add these two constraints, what that should do is that should constrain it to the top and bottom, or the left and right side and the top and bottom of the screen. That guarantees that all of our stuff is going to go inside of this stack view. Now, we don't have anything in it, so it's going to look kind of boring. Let me make this bigger again so we can go through and do that. Now that I showed you how constraints work. Stack views make it so you don't have to worry about the constraints inside of them, because you can just set some rules for it and then it'll just kind of calculate those. So we would like to probably take a look at all the different types of controls we have. There's a lot of cool things you could do in here. Let's start with the most basics, right? You know, you probably want like a label. You probably want a button and like a text field, right? Why don't we do that to start out with? So let's just start out with like, I don't know, a hello world kind of thing where we could say their name, the normal demo that you'd want to do when you're throwing something out, right? So we'll throw a label out here. We'll say, hey, stack layout. And it's really important that we make sure that the label is inside of the stack view, because otherwise this magic won't work. And you just want to make sure there's a little tab indentation when you drag it in. That's the way I like to do it, at least. We're going to make a text field. So let's make a text field and drag that right next to it. And then we need a button, you know, to kind of do our interaction here. So let's just do this filled button. And so now we have 3 components out here. Now, we want these to be a little bit bigger, right? So what we can do is we can put some constraints in on these now. And so what we want to be able to do is say, look, man, I want the width of this to be like, now this is Apple TV. So unlike most states, you know some pixel coordinates. For example, we know that this TV is 1080. That means it's 1920 across by 1080 wide. That's how many pixels. And so because we know 1920 by 1080, we can actually play around with pixel counts and not necessarily be hurt by that. Now, I will admit, 4K TVs are going to screw you up here, but that they do double pixel density usually on that. So this shouldn't, by theory, harm us all that bad. But we'll find out in a few seconds here. We'll test that. We're going to say that we want this then to be width of 500, and that should make us a little bit bigger box. In fact, I'd even argue that maybe even bigger than 500. Maybe we should go, since we know it's pretty long, let's make it like 800. That seems like it's cool. Oh, we already got our first problem. The constraint system is mad. Why is it mad now? Let's take a look and see what because we have 2 different constraints. We have an equal and then we have less than. We can't have 2 of the same constraints. We only can have 1. In order, it's like Highlander. There only can be 1. Now, if you look here, instantly the rest of the UI started to automatically stretch. Now, why is that? Because the stack view automatically inherits from anything inside of it. And that's pretty cool. Now, these are too close to each other. I don't like that. So we can go into the stack view itself and see this distribution. We could change it and say, you know what? We want some equal spacing. And we're going to also add some spacing elements to it. We're going to say we want about 40 pixels of spacing. Let's make that 70. That looks a little bit better. Okay. We're still not done though. I'd like my label to be centered. So I'm going to go into my label here and I'm going to click the center button and that should center my label. Now this is starting to look pretty cool here. Now, folks, one of the coolest things is we have yet to write a single line of code. We have not written any code whatsoever. We're just using Xcode in the UI designer. This is one of the coolest things I loved about storyboard files, is that you could build something pretty quick as a prototype because you weren't writing a lot of code. And a lot of people say, no, you should write all these components by code. You know, you should be using Swift, and you should have a UI label, var variable there and stuff. Each your own, buddy. Each your own, right? If that's what you want to do and that's what makes your life good and stuff, that's great. I actually like storyboard files. I'm one of the few people. I've written a lot of code by hand, but I've also done a lot of projects with storyboard files, and I'm telling you, storyboard files are faster if you know what you're doing. The amount of constraints you have to write by hand can get really large and boring, and they're buggy. I can visually see all these in Xcode with a storyboard file. I don't have to worry about it being as buggy. And that's something that I really do enjoy a lot. All right. So let's see here. So we've got our label, we got our button. We can even put text on the button. We can even say login or something like that, right? If this was like a login, maybe this is like a username and password box eventually. But we could change the text here. We don't even have to write it in code. We could just go in here and change the freaking text, which is pretty awesome. For our label here, we'll just say we'll put the word hello in to start out with, and we'll put a comma and space there. That sounds like this all sounds like it's like normal crap we'd want to do, right? Let's go ahead and close this out to start with and then check to see if it renders or not. And we're gonna come back. So we're gonna go in here, click the close, and it says, hey, do you wanna save this? Now this is where the magic sauce happens. We didn't make any references to the UI stuff. Oh yeah, TG Gamer says, I have loved Flutter recently, how much I prefer coding the UI approach over XML. However, design and layout is hard to flow. Oh boy, let me tell you, I've got a project at work I wrote in Flutter, and it is so nested that you go into this nest tree and it's like literally like inside, and it's like the Pac-Man backwards, right? And it's so nested with little tabs to try to get over to the component that by the time you get, if you have like a page you're looking at, it's super hard to read. And I'm using block to try to make things easier, the block pattern, but it still is like very daunting to read, to tell you the truth, and just to see what's going on with the UI. So I'm with you on that, TDG Gamer. That's Flutter can get the code can get very hard to read, and there's something to be said about the coolness of the interface builder kind of stuff. Now, magic just happened. Now, no magic techniques being happen right now, and I want to explain why. So I have this view controller here, right? Oop, no, don't do anything. What are you doing here? I don't know what it just did. It shouldn't be doing anything. If I go into this designer file, you'll see it's blank. All that's there is something called a release designer outlets. All right, so what the heck are outlets, Aaron? It's a good question to ask. Outlets are pointers to our elements that come off a storyboard file. Think about it like this. What is the real magic behind a storyboard file? I was a tech lead for years in Xamarin, so I can tell you all this. Storyboard files XML that gets serialized up. So when the view controller comes into memory, it actually behind the scenes, it's taking the XML, it's serializing up, and it's making it's stashing all the objects. Now, in order to see which UI elements that you want to have pointers to in your code, that's what we call outlet. Now, when the screen leaves memory, right? It leaves from the screen. We need to get rid of all those outlets because otherwise they'd be in memory forever. There'd be a memory leak. And so what ends up happening here is this release designer outlets is designed to say, oh, all these references to these UI components that are on the screen I no longer am rendering, I need to get rid of those out of memory so that we can clean it up. Remember, .NET is a garbage collection language, and so that's what that's designed for. But you'll see here, nothing happened, and that's on purpose because I didn't make any outlets yet. I just want to run this now and see whether or not I can see my UI components. So that's what we're going to do here. Now, over in Visual Studio, we use the play button, but over here, we got this build solution button. You can see here, it automatically knows the Apple project here, and it knows the emulator to use. It's smart enough just to know all that. Writer, once again, Writer, pretty great. I have nothing but good things I can say about Writer. So let's go through and see what happened here. It should build, and then if we go back to our simulator, hopefully it should run. Oh, I clicked the build, not the run button. Let me run it. The unable to match without code setting. There's no code setting. C code setting key. It should be code setting should be my developer automatic. That should fix it. So I forgot to set a certificate for this. So this is kind of crazy how we have profiles for applications in Apple's world, and you have to have a developer account for this. I already have my developer account set up on this machine. I could just tell it anytime it builds a new application, just build a new profile for it. So we look here, man, we got it. Look at that. We got an Apple TV app running. We've got hello here. We've got a little box here that I can't do anything with yet. And I'm not sure why. But we have a button also. Let's go in here and see whether or not, like, I know there was for a while here that you had to use the arrow keys and click enter to get there it is, the keyboard. So you can't just click in there and type because it's an Apple TV. You have to emulate the controller. So you can see here, the only way I got that text box to type, and now I can say hello. I can say Aaron, for example, and click done. And tab down to done because I can't click on done because once again, this is an Apple TV. And then I could click the login button, but nothing happens because I didn't wire anything up, right? So we have to remember, I'm using the arrow keys right now, the arrow between these two components, these two controls, this text field and stuff, because this is an Apple TV. It's not a Mac. And your mouse doesn't mean anything. You can click all you want here, but it's not going to do anything because we're on a Apple TV simulator. So let's go ahead and close this out and see whether or not we can add some functionality to this puppy and see how far can we really go with this thing, right? And the answer is you can go very far. I have written some pretty complicated stuff with this, and it worked pretty awesome. So I'm going to go back to my main storyboard file. I'm going to right-click and say open an Xcode. And we have our Xcode interface builder. Of course, it's off screen, so let me get this back on the screen. And we can take a look here and see how do we do this. Now, you have to know a little bit inside baseball about how Apple TV apps used to be built prior to Swift. And so if you're a Swift person, you're going to be really confused by the idea of a header in an M file, the implementation. These are for Object-C. And so we're going to have Xcode write some Object-C code for us. And what's going to happen is Writer is going to automatically convert that to C#. Say what? Yes. That's what's going to happen. That's the magic sauce behind this, and this is why it's so cool. So how do we do that? Well, it turns out we don't even have to write the code. We can have Xcode write it for us. We're going to build outlets. And so how you do that is you need to have your UI open, but you also need to have your code open. So I'm going to actually use this little plus button here to say I want to have two things open at once, and I'm going to use this to bring in my header file. It is very, very important that you understand that you must do this in the header file, not the footer file. If you do it, or in the implementation, if you do the implementation, bad things are going to happen. It's just not going to work out for you. Now, because we are on a stream, we're limited to our UI. We're going to go through and hide some stuff so we can see things better. And I'm going to try to describe this the best as I can. I like to use this window over here that gives you the ability to see your view. And then when you click on your view, it allows you to see what's inside the view. And then I can individually select the UI components. Hey, Jonas, how's it doing, bud? I hope you're doing well. We're playing around a little bit here during lunch hour with doing an Apple TV app in UIKit, but running it in .NET. And we're making some outlets. So welcome to stream. Jonas is a second-time watcher. Came on yesterday during our Swift stream, and we had an awesome talk about threading. It was a ton of fun. We wrote a bunch of code. We proved out how threading with background should work in Swift. It was really great. So welcome to stream again. I really appreciate you for jumping on. We had fun yesterday. Hoping we have a little bit of fun here today. The little bit of time we have to stream. So I've got my label. I've got my round text field, and then I've got my login button. So how we do this is you have to use your finger and the keyboard. So we're going to hold the Apple key, and we're going to click on this, and we're going to hold and drag over to our I lied. We're going to hold the control key, and we're going to drag over to our code file. So what I did was I held down the control key. I have the component selected, or the UI that I want, right? And I'm going to drop it here. And it's going to say, I would like to make an outlet for you. Now, there's two types of things you can make. You can make something called an outlet and an action. An outlet is a pointer to that UI control. So this would be a label in this sense, right? So I need to give it a name. Now, usually, like in .NET, we would do camel case. So you have something like LBL that stands for label. And then you'd say message, for example, right? Some developers just like to say message label. This is more of a VB thing, right? If you're a .NET person. I don't like that. I like label message. I think that's pretty good. It needs to be a weak reference. And weak and non-atomic means it has to do with reference counters and when we get rid of things versus not getting rid of things. If we don't do this as a weak reference, we kind of talked about weak references yesterday. This will keep an extra pointer to that component way longer than we want to. And when I say component, I mean a view or a control. I'm so used to talking to React developers now. Everything's our components, but over here in mobile land, these are not components. These are controls. So I'm going to do the same thing here. I'm going to go into my text field here, and I'm going to also go through and make an outlet to that. And I'm going to call this, this is the text field, and this is going to be our input, our message. We'll call it our input message field. That seems like it's, we're going consistent here. Now, login's where it gets interesting. We have this button, right? Do I need a full pointer to the button? And the answer is probably not. I just need to know when somebody clicks on it, I want to do some code. I want to run some stuff, right? So because of that, you have two choices. You could make an outlet to this, and then you could subscribe to the message, and that's how Cocoa. So Object-C works is that we send messages into things. It's just a terminology thing. So we can send a message in to say, hey, look, whenever somebody taps on this, I want to run this code. And that's also an event. You could call it that. And it means the same thing. It's just terminology. If you've long-term Cocoa and Object-C developer, you're going to talk a lot about messages. But messages and eventing and these kind of things are almost all interchangeable. They're just terminology based on the framework you're using. So I want to just get the message, the action of when somebody taps on this. I really don't care about the actual button itself because it looks kind of nice as it is. I don't need to change any of its properties. And I already got it set up here in this storyboard file looking pretty good. So I'm just going to drag over here. And now you can see here, it has options for outlets or actions. I want the action. And what I'm going to do, I'm just going to say button clicked. And we're going to say type of ID. And that's kind of important. We want to keep ID there. This is the type of thing that's going to pass into it. And the argument will be of type sender, which means we're going to get a pointer to whatever button that basically did this. The person that is telling me that this thing was clicked, I can talk to that thing via the sender. Okay, we're going to click connect. And now you'll see here, I'm going to click save here. But you can see here, I have a different type of code here. This is all Object-C code. So we have three things that we created here. We have two properties. These are just like public properties in .NET, right? We've got a pointer. We know that's a pointer because we have a little star here to our label message. We've got a pointer to our text field. And then we have a action or a method that we can run, a function, action, and method, event. They all are very similar terms for the same thing. We can see here, I told you that it was type of ID, and we're sending in the ID of the sender. And the sender is going to be whoever that was this button that tapped it. So I can find out who did that, right? And maybe you want to change the color of it or put a little spinner on it while you're doing some work. Well, you have a pointer to it, so now you could go through and actually modify the button if you wanted to. This is all the things we want to do here, but we didn't write any code. We just drew some lines in Xcode, and it wrote us Object-C code. That's Object-C, folks. That's old school stuff. That's not even Swift, right? Well, this is where the magic happens. This is where I'm saying that Visual Studio for Mac and Rider have this functionality. VS Code does not. I'm going to click the close button here. It's going to say, hey, are you sure you want to save this stuff, man? And the answer is yes. Now, how does this really work behind the scenes? What's really going on here? How does the magic really work? How the magic really works is that I've talked to the people that wrote Visual Studio for Mac. I've been a guest of Microsoft stuff for years. In fact, the relaunch of Visual Studio for Mac in 2019, I was actually on campus and I did a little video with them on Channel 9. You can go YouTube that if you want. It was called Visual Studio for Mac Refresh. I was on there. I showed off some of the stuff that we were building at EY with Visual Studio for Mac, which we did a lot. But how it works is there's a file watcher that watches the storyboard file and also these header files. And anytime they change, that watcher, the file watcher, will kick off an event, and then they go find the changes that you did, and then they write the C# code for you. And the magic should be is if we go into the view controller designer file here, we should now see those outlets in C#. We looked at this earlier. There was nothing in here, but look at this. Now we have three outlets in here, or two outlets in an action, right? And this is I was telling you about it. This is our function then, right? This is a partial class in C#. So partial classes mean that we can define them here, but put the implementation inside of the other file, the non-designer file. This is something that came out in, I don't know, .NET 6 or 7, I think. Or excuse me, C# 6 or 7. .NET versions are different than C#. But I think this came out in C# version 6 or 7. And you'll see here, this is where I was telling you about we have to release memory. So we check and see whether or not these components or these controls are still in memory. If they're still in memory, they're not null, then we need to dispose of them using the iDisposable pattern. And then we mark them as null, guaranteeing that they're no longer in the garbage collector for memory. And so that's the goal of what this is doing, which is kind of crazy, right? So the cool thing is that if I go to View Controller now, you can see here, I've just got this constructor. Now, this is the hardest thing to understand inside of this world of AppKit. And this works for Mac applications if you want to write Mac applications in C#, if you want to write iOS applications in UIKit, or Apple TV here, and even Apple Watch. Anything you're using non-Swift UI, these are the rules. Okay. One, this native handler is actually a pointer to the actual view controller inside of the storyboard file. Never change this code. Okay. This constructor must be like this. If you change that, it won't be able to pull the view controller out of the storyboard file. So it's very clear that this signature of this view controller should be there, but you never want to run any code inside of this constructor. I can tell you 95% of the time, if you run code in the constructor, you're going to be sad panda. There's two methods you care about in the world of UIKit. And AppKit is almost the same thing. We have a view did load and view will load. So we could just go in here. I'm using the VI plugin. So I'm going to say override, and it's going to give us a list of methods we can override. So we can say view, and you'll see here did appear and did load. View, did appear, and load are your two friends. They are used for different parts of the rendering lifecycle. And so view did load is really important. This is going to be when the VUI is already up and running at this point in time, okay? That means that all the components are already in memory, they're already on the screen, and they're ready to go. View will appear is for before that. And you need to understand that. Now, here's the trick of the trade. View will appear does not always run multiple times. View did load may also run, may or may not run multiple times based on whether or not constraints have changed. Say, for example, you have something that's hidden on the screen, you click a button to show it. Well, when that happens, the constraints will change. Some of these methods will actually run again in the lifecycle because they have to recalculate constraints. And this has to do with how iOS and UIKit and AppKit's lifecycles run. And you learn this over a period of time, which methods to use when. And there's also certain things you could do to try to guarantee that the constraints will recalculate out. These are all for a future stream. We only got an hour today. We're streaming an hour every lunch on the topboat.net. So in this stream, we could get... I could go hours and hours and talk about this, but we just want to do something simple and easy to prove out that this actually works and is pretty cool. So we need to always call our super or our base, and then we could do some cool stuff here, right? So one, let's just check our variables. We should be able to do label, LBL message. You can see there's our label for our message. We can change the text of that right now and say testing, changing the message. Or we could say, hello, please type in your name. We'll do that. That's probably a better thing to do here, right? Now, since we have a partial class, we also can override our button click. So we can say override button, or actually I think we don't even need override. We just need to say button. There we go. There's our partial. And so we're going to say we want the implementation of that, right? And so this is what's going to happen when the text field is clicked. So the first thing is we know that the person has typed in some stuff into the text field. So let's get a variable to that. So we can say text field, we can say var name equals text field input message dot text, and that should get us the text for it. And now what we can do is just modify the label. We can say label message dot text equals. Now this is where if we want to append it, we could append it, but remember in C#, anytime you start to add or concat strings together, you're making a new string, and that's not necessarily good. We could use string interpolation to do this. For right now, we could say, nice to meet you, and we'll say dollar, let's see here. If I remember right, it's $, and then we put it, I write in so many languages, I have to remember the syntax for this, and I think it's this for C#, if I remember right. Swift does it with slash parentheses, and then Kotlin does it different, and so Flutter does it different. So it's like sometimes when you have to know a bunch of different languages, one of the hardest challenges is remembering which syntax to use for which language, especially with C#. It looks a lot like Flutter, right? And Swift looks a lot like Kotlin. And I can't tell you how many times I'll get halfway through writing something, I'm like, why doesn't this work? And it turns out, oh, because I just wrote Kotlin in Swift. That's great. Sorry, 1 second there. Had a hydration break. So we've got this wired up now, where when we click this button, we should be able to do something. We should have the message change. This is the most basic POC in the world you can do. You really start relying on the squiggly, out of these squigglies. Absolutely. I'm a big fan of also warning messages, and I give a lot of lectures, especially when I'm running teams about developers that ignore the warnings. The warnings are usually there to warn you that something's wrong. Compilers are good enough these days where if there's a warning, it's probably something you should be concerned about. And so you should probably look at it and try to fix it. But yes, the IDE is your friend in here. And you can see here, it's giving us an underline here. It's only doing that because it's telling us that this is string interpolation. But you can see here, we've got a squiggly here. It's saying, hey, it doesn't match the rules because I'm an idiot. I've been doing Swift a bunch of time. In .NET, we do things based on uppercase method names. And I did lowercase because I've been writing so much of other languages. This is more of a code. This is almost like a code standard in .NET. It's warning me I'm not following that. Now, you're going to say, well, geez, Aaron, you could just right click and fix that. Ooh, that's a bad idea. Bad idea. Danger, danger, danger. Okay. Stranger danger. This will get out of sync with your storyboard file. And that is badness. You don't want that to happen. So you have to resist the urge of fixing it here. Okay. The only way to fix this is we got to fix it in the actual code in the storyboard file and repoint it to this new method, because if we don't, bad stuff will happen. Okay. I can just tell you this from experience. Do not resist the urge of just right clicking and saying refactor and rename. Well, I can just rename this. Why can't I just rename this? This seems like it makes sense, right? The refactoring in C# does not know about the storyboard file, and it's not going to modify your storyboard file, so it's not going to fix it. And that's going to end yourself in a world of hurt. Now, if you're a super nerd and you know the syntax of the storyboard file, you could technically speaking go in here, find the button, change the method name, and then refactor it, and it technically speaking should work without problems. And we can prove that if we go find the button here, we'll find here is the right here. You see the selector right here? I could change this and say this is going to be capital B instead. If I did that now, we're out of sync. But don't worry, we're going to fix it here. And then now, if I also fix in my designer file, no crap, no foul. If we go here and look here, now everything should work. This should no longer be squiggly lined anymore. Remove the... I don't know why SolarLint's telling me remove the unused private method button. Click. No, I'm not removing that. Oh boy, that's not what I wanted. No, I shouldn't have to remove that. I'm not sure why it's saying that, but we fixed the naming convention problem here. And that should be, let me make sure that's also done here, right? Yeah, it's done right here. It's not complaining here. Let's run this and see what happens. There we go. Complaining went away. It's all right. Things are good. Yeah, you just got to pick your poison, right? At some point in time. So, not recommended if you're a junior developer. If you don't know how storyboard files work, do not do what I just did, because you have the possibility of really destroying a storyboard file. Now, remember, I have one screen. I've had storyboard files with 50 screens in them. I'm not kidding. And so when you destroy that storyboard file and you have to go to try to find that needle in the haystack of what you broke, oh, geez. The other worst thing in the world is you have to do a merge conflict with the storyboard file. It is a nightmare to try to go through and say, oh, somebody changed this and you changed this and now they no longer match. I've seen developers live and die off of trying to do a merge conflict on a storyboard file. And the answer is just don't make it happen. We used to literally have a rule where only one person could work on the storyboard file at once. We used to use Slack, and we would send people messages. Hey, man, I'm checking out the storyboard file. Nobody touch it to the rest of the day. Everybody like, oh, okay, back off, man. Back off. That's a loaded gun there, because that way you don't have to worry about the merge conflict. Now, most of the time it was fine. Here's what happens, right? If you are working on two different view controllers in a storyboard file, you're probably fine. That merge is going to work without problems. It's resisting the urge to go and edit something that you're not supposed to. Like if you're assigned to work on a story, like a story in the backlog, and it's only one view controller, and you're working on it, but you look at this other one and you go, oh, geez, look at that. The person used the wrong font over there, or it's the wrong color, whatever. I'm just going to fix it for them. But they're also working on it. And so you then are trying to be a good citizen. You're just trying to go through and fix something you saw. But now somebody else is also working on the same thing. That's your merge conflict right there. And that's almost every single time I've ever seen this happen. That's how it always happens. It always sounds innocent. I used to have a guy I work with named Joe. And Joe, I remember one day Joe came up to me, rest his soul, and said, hey, man, merge conflict in the storyboard file. I'm like, ooh, what happened, man? I'm like, dude, that's not a very big app either. I'm like, what happened? He said, well, I admit it, I did it. I'm like, what did you do? He's like, remember yesterday when you added the stuff in there? I'm like, yeah. He's like, you put the wrong font in. I'm like, oh. because we had a custom font and this and that. And I was like, oh, okay. And he's like, yeah, but you were already still modifying other things. But I fixed that. But now there's a merge conflict. Like, oh, shit. That sucks. He's like, what do we do? And I was like, that's a good point. I'm like, well, this merge conflict was pretty easy to fix. It was only a couple lines, so I could go through and read the XML and figure it out. But sometimes you have to take one and just say, this one wins, and I'm going to have to refix the things that aren't there, right? Or you could try to merge the two things together, but it's usually kind of a nightmare. And that's the one negative against storyboard files that every single developer will tell you that's why they hate them and they shouldn't be used. I'm not saying they shouldn't be used. I say that they should be used just like any tool when it makes sense, right? For me and for a POC, I'm just telling you, I'm way faster with a storyboard file than I'm ever going to be writing code because it's so easy to drag and drop this crap, man. It's awesome. But I fully admit, if you're on a big project with a lot of team members, storyboard files can be really painful. Now, remember, we're in our simulator here, so we don't have the ability to use the mouse. We have to click on the box to type in stuff. We're going to type in the word Aaron, and we're going to arrow down, use our arrow keys to done. And then we're going to click our login button. And that code should run. And if everything works well, we should maybe get my name changing here. But we crashed. Look at that. We crashed. Man, that's not good. We seg faulted. Look at that. A native stack trace. We did bad things. We did bad things. And I'm pretty sure I know what we did bad. Oh, look at this. Apple TV. Unexpectedly quit. All right, where do I think my problem is? Well, we can put a breakpoint here and find out. My guess is that there's a possibility this is not running the main UI thread. And if this is not running the main UI thread, you try to modify something that is on the main UI thread, chaos will happen. Let's put a breakpoint in here and see. That's usually what ends up happening here, but usually anything in view controller usually starts off in the main thread. So that's usually not the problem. My second guess is that this input message text box, for whatever reason, is not have any text in it. And so if we do that, that's also could be breaking it. I'm having Windows Forms flashbacks. The button click should be on the main thread. It absolutely should. But I'm thinking of like why I would get a seg fault. And these are the only reasons that come to mind really quickly off the top of my head of like why we would have that. So let's just go in here again, type in the word Aaron. We're going to click login. We'll get our breakpoint. And we'll see if our breakpoint hits. Man, we are doing a lot of crap here. Yeah, we're not even getting to the breakpoint. It's the name of the method change. That's what did it. Remember, I changed the method name? That's what I bet you broke everything. Is that there's still something out of sync between the method name here. So what we could do is open it back up our storyboard file in Xcode and go take a look at it. I'm guessing our outlet doesn't match for some reason. There's something that I missed, and that is probably causing the chaos because this should just work. So if we go look here and see, there it is. See this? The header file still think it's called lowercase button instead of uppercase, and that's where our problem is. And so I renamed it, and like I told you, you could try to go in and change the storyboard file, but remember how I told you if you do that, you're probably going to break everything. You should go back in Xcode and rename it, resist the urge. I did not resist the urge, and look what happened to me. I literally busted things. So I'm going to go ahead and click save here now. And now what should happen is it's probably going to be pissed because of the fact that there's something already named that. And my guess is sometimes you'll get two of these. And that's what happened. We got two of them, right? So now we have a problem that this is twice in there. One for the underscore, the lowercase button, and one for the upper. So let's go ahead and click, delete that one. And now we have the outlet to the proper named one. And now Magic Sauce should work. This should all work. So troubleshooting 101. What did we learn? We learned when Aaron said, do not refactor your C# code from an outlet or an action, he really meant it. And I unguardedly did it, and then now showed you what happens if you do not follow the rules and follow them critically. It's bad. So let's see here. What's going on here? A connection refused. Let's go ahead and restop and start our emulator because now I'm sure our simulator is just mad. Yeah, our simulator is still running the app. So it's you can double click the home button here usually, and it will show you any apps that are running, and then you can swipe up to get rid of them. That's a trick to get rid of it when you have like a crash like that. Let's go ahead and click the run button again. And by theory, we should be able to get our breakpoint now. We shouldn't have the chaos that we're getting before. And let's go back to our simulator. It should not open up automatically. We'll have to do that here. Let's go ahead and type in our name in here real quick. I'm going to click here, hit Aaron, do login. Nice to meet you, Aaron. There, look at that. We didn't break anymore. Woo-woo. We get it. We did it. We got an Apple TV app working. It done it. Literally. Yes, that's right. We learned that if the tooling makes something painful, there's probably a reason for it. There's probably some stuff here we didn't think of. And honestly, it's something I just forgot. When I looked at the outlet, I should have also saw the annotation for it here, right? This is the name that what it is in the header file. And if I would have just renamed the method and also then renamed the annotation right here for it and then did it in the storyboard file, it would have worked. But I missed the annotation here. And this is why I was saying don't do it, because you're going to do that. You're going to make that mistake. If you try to do this by hand, by manually editing the storyboard file stuff, I guarantee you something's going to go wrong in the world and you're probably not going to like it. All the stuff is designed to work in a very specific way. And then when you follow the rules, it's actually kind of cool. I mean, think about it for a sec. They have a file watcher that's watching the storyboard file. They serialize all the XML. They figure out what to do, and they auto-generate some C# code. Now, remember, folks, this technology was around in 2012. 2012. Source code generators in C# are a new thing. So this was a company, and it wasn't even Microsoft that did this. This was a company called Xamarin. This company had the coolness to figure out how to write an auto-modify code on the fly based on you modifying some stuff in iOS. And remember, they're the ones that figured out how to compile this stuff down so that it runs AOT on an iOS device or Mac or Apple TV in bytecode. So this is running like to the operating system, Apple TV. This app, it thinks it's written in Object-C. It does not know the difference. That's pretty badass cool. The fact that they figured out a way to do this and they have the technology behind that. That just shows you that if you have an idea and you have enough time and money and intelligence about a certain platform, you can build a lot of really cool things. Here, and Xamarin at the time was a very small company. Very small company. I was a customer pretty early on, and I know that their customer list, at least when I talked to them, because we were paying a lot of money. Xamarin originally was $1,000 per platform per developer. So it was about $1,000 for the iOS license and $1,000 for the Android license per year per developer. $2,000, folks. And we're talking 2010 money. This is before inflation, right? So it was not cheap. But if you had a bunch of .NET developers that did not want to learn Java or Object-C, it was pretty cool. It was pretty cool. I had all the same tools. I agree that the .NET landscape changed forever when Microsoft swallowed up Xamarin. Are we better off because of that? I don't have the answer for you on that, to tell you the truth. Some people say I'm a Microsoft fanboy. I don't think that that's true. I'm a fan of some of the things they do, and then I'm also kind of critical of other things. Xamarin, when it was a startup, had the ability to do innovation. They're constantly innovating because that's the only way that they can make money, was to innovate, right? Now that that's kind of gone and they've been swallowed up by Microsoft, Microsoft just decides not to fund things randomly, and then when they don't fund it, it just goes away. And so many things that were cool have gone away because of the fact Microsoft doesn't want to fund it anymore. Visual Studio for the Mac is a primary example, right? So once a corporate takes over something, I don't think Microsoft always makes the greatest decisions in the world. Now, you can say, well, it's a niche market, right? Visual Studio for Mac is an extremely niche market. Writer is doing it better. Why would they even try to compete in that market then when there's something else out there doing it and doing it better? Well, I mean, I kind of like Visual Studio for the Mac because it's keeping Writer honest in some sense, right? You have to have competition. The more competition you have, the more likely things are going to get changed for the better. When you don't have competition, that's bad. So I kind of liked it when Visual Studio for Mac was out there because we had a very thin and easy to use IDE that maybe didn't have all the bells and whistles, but it was very much like Xcode in the sense it just did one thing and it did it pretty well. Now, I know some of you are going to yell at me, oh, Xcode is pile of garbage, this and that. Man, I used it for years daily. It's fine. It's fine. As an IDE, does it sometimes break? Yes. All IDEs, if you use them enough, break. That's the first thing. Second thing is, for what I needed to do, it doesn't get in my way. It does things pretty great. There's a couple things I wish it did. I don't like having to do build watchers sometimes via the LLDB commands. I feel that I have to Google those sometimes to remember how to do that. Yeah, and I mean, so Xcode can have some stability problems from time to time, and that's not fun. But Yeah, man. Thanks again. I'm gonna end this stream here pretty quick here because it's only a lunch hour stream. But yeah, it really is. It really is to the point where all IDs have problems. If you've been developing enough, you're gonna find like Android Studio. Oh boy, I have daily problems with that thing. Anytime I touch it, it seems like something weird happens. But we did some cool things here today. In an hour or less, we got a POC running of Apple TV running. We showed off all the internals, how you can use storyboard files with and stuff with that. Tomorrow, we're gonna do the same thing, but with a Mac application, and that's gonna take us a couple days because we want to do some stuff with Windows and play around with it a little bit more, get some table data running in it, and show off like how you can do all that kind of cool stuff, and show how it's different than Windows Forms. And WinForms is the alternative to in .NET. That's how we would write in the old school way of building a Windows app. And I've got a lot of experience with WinForms, so we can kind of take a look at AppKit and see how to do that. So, folks, thanks everybody for attending the stream today. These will be up on YouTube and archived if you're interested as .NET people or just learning about some of the weird stuff you can do with it. That's what this stream is for. We'll be streaming Monday through Friday, 1 hour a day from 12 to 1 p.m. Central Standard Time. I want to appreciate all the people that joined me in chat. And if you're watching on demand, just remember, be nice to each other, man. We're all in this together.